Hi, this is Nick Carnick. Today we're going to talk about React Component Lifecycle. React lets us define components as classes or as functions. A component class can be defined by extending react.component. The only method that is required in a component subclass is render, as you can see in this block of code. Components have several lifecycle methods that you can override to run your code at a particular time in the process. These methods are categorized into 4 groups: mounting, updating, error boundaries, and unmounting. In this example, we will build a counter component and utilize all the lifecycle methods. Let's get started with creating a constructor. A constructor takes props as its object, and we need to call the base class or the parent class method via super and pass in props. What this does is it sets this.props to props, so it's available throughout our class. Constructor is also the only place where we can set state. So let's go ahead and set a counter, and let's use that in the render method. All right, and I also want to have the console open here. And while we're looking at the console, I want to make sure I'm printing messages in the various functions as well, so we can see the progression. So when an object's created, the constructor is called, followed by render. Let's give this some functionality to increment and decrement the counters. So I'm going to create a couple of methods here. Increment, which will set state on the counter and increment it using the previous value and add 1 to it. Likewise, decrement will decrement a value on that right here. Okay, and let's create a couple of buttons to allow us to increment and decrement this. We're going to assign these methods to one of the events for onClick. And let's replicate that for decrement. Oops. There you go. So now when we click this, we're going to see the counter reflect the change. And notice that all it's doing right now is calling the render method. So let's introduce a few lifecycle methods. The first one is component.did_mount. This is called right after render. Now when I save this, we'll see things re-render. And what I want to do is also add markers at the end of some of these render life cycles. So we're just going to add a dashed line so we know that this is a single render call. And if we were to do increment, there is another render call. But it does not call component.did_mount because that is only triggered when the component is constructed and essentially gets added into the DOM. However, there's another method called component.did_update. And this method actually takes a few parameters. There's a reference to previous props, the previous state, and snapshot. Let's trigger component.did_update, and we'll add a log statement here. All right, so notice that component.did_update is not called here. Once we click increment, we'll see component.did_update. I want to add a line marker there as well, so we know that's another render. So if I click this, you see the different sort of life cycles that are triggered. All right, so let's go ahead and add the ability to mount and unmount this counter. We need to do that in app.js. So we're going to create a constructor here with props that are passed to the parent, and then set state in the constructor to with an attribute called mount, which we'll set to true, and a couple of methods to mount and unmount the counter. We'll set state here to set mount to true, and likewise this will be unmount counter, where mount will be false. Let's go ahead and create a couple of button elements, mount counter, and map its on click to this dot mount counter, and replicate that for unmount counter. Okay, so another thing I want to do is set disable to true or false depending on the value of mount. All right, so notice that the button's just grayed out now. And if I click on mount, in mount, you'll see that some lifecycle methods were triggered. All right, but one of the things we forgot here is to take advantage of that state variable. So I'm going to use that and conditionally render counter. And if it's not set to mount, we'll remove it from the DOM. All right, so there you go. So now this should actually remove the counter. Let's add another lifecycle method in counter. This time it's called componentwillunmount. As the name suggests, this method is called when a component's being taken out of the DOM. And let's add another marker there. And there you go. So now component did mount. If I click on mount counter, you'll see component will unmount was triggered. And there you go. On mount, the constructor is triggered because the counter component is recreated. These are the most commonly used lifecycle methods. Let's shift focus into some of the infrequently used methods. We have another method called shouldComponentUpdate, which takes next props and next state as its parameters. Generally, this returns true by default. The purpose of this method is to let React know if render should be triggered or not. Normally, React does a very good job at figuring that out, but sometimes, let's say your state or props gets updated and you don't really need render to be triggered because you're not changing anything on the UI. And especially if your render method is a bit expensive to compute, then you can definitely gain some performance here. But you need to be careful here because you could fall into a trap where you end up losing performance if this method is used incorrectly. Let's add a prop in app.js that we're going to pass into counter, which we would want to ignore. Okay, so let's call it ignore prop. And whatever the value here is, let's say it's 0 initially. I'm going to create another method here to pass in ignore prop by generating a value and assigning it to state. So ignore prop is just add the random. We don't care what the value is. What we want to do next is pass that prop into the counter. So we'll pass in ignore prop equals this dot state dot ignore prop. Okay, and so that should pass this through. But what we also need is a button to trigger the change. So let's call this ignore prop, and then on click we will call this dot ignore prop. Okay, there you go. So now when I click ignore prop, it's going to call render and component update, mainly because something changed on the parent and that was passed down to the component. But in this case, let's say we don't care about ignore prop because we're not doing anything with it. We're not rendering it to the UI. So we simply want to ignore it. And that's where this method comes into the picture. So we'll create a condition here to check for when it's appropriate to tell React not to call render. We're going to store this in the state and call it ignore prop. If there is an ignore props value, and if the one in our state is not equal to that value, we want to return false. Basically, anytime ignore prop comes in, and if the value doesn't match what's in our state, we want to return false. So it's still being called here. That's mainly because we should check this dot props. So we're looking at whatever's in our current props, and if next props is different, then we know ignore prop was changed, and in that case we don't want it to render anything. Let's add a console log here as well. Alright, I click ignore prop, should component update is called, but let's look at this. So it's going to render for some reason. We're checking if the value exists, and if that value is not equal to what's in our props, if that's the case, we do not render. Perhaps we are looking at something incorrect here. Let's see. Ignore prop has been passed in there. Oh, this should be ignore prop. That's the issue. All right, there you go. The next thing to look into is a method called getDerivedState from props. This is a static method, and it's called before every other method. Oops. And this passes in props and state. And the purpose of this method is to give you a chance to copy any values from props that you may be interested in transferring over to state. And in our case, we could add another method here that allows us to pass in a random seed value. So let's say we start out with our seed being some arbitrary value here, and what we can do is add a seed generator method, which is simply going to set state to set the value in seed to an integer. So we're going to parse int and do mat.random times 100 to scale it up, and that creates a method for us. And we also want to pass in seed here from this.state.seed, and also create another button here that maps to seed generator. So we can call it generate seed. All right, and I think the error we were getting earlier here is that we don't have a return statement. So anything you return from here gets assigned to the state. So if you don't want to change state, you simply return null. All right, so now when I click generate seed, let me lower this. Nothing seems to happen. I mean, we see some lifecycle methods getting triggered here, but it's not really taking advantage of the seed being passed in. So let's take care of that in this method here. So we want to check if a seed exists on the props, and if the seed that's in our state is not equal to that seed that's passed in. If that's the case, we will return a seed value that's props.seed, and set the counter to props.seed as well. And let's just default it to 0 here in the state. Notice that counter starts at 40 because we had set the initial seed value to 40 here. So I can click increment and decrement, and this continues to work. But I could also click generate seed, and that should change the value of counter here. All right, but the point here was to demonstrate this lifecycle method that allows us to copy props into state. Notice that since this is a static method, we don't have access to the instance of the object. There's one more or a couple more methods we need to talk about. So the next one is called get snapshot before update. And that sort of goes right before render. And it takes in previous props and previous state. And then we return a value out of this. This method is to allow us to capture some properties that are not stored in the state before we re-render that component. So let's say you had a list view or a text area where the cursor was on a certain row and column, or if the list was scrolled to a certain location, then you would be able to capture details about that and then handle that later on. So whatever is returned here gets passed into component.update as a third parameter called snapshot. And that's where we could tell the DOM to sort of set the cursor and the caret in a certain place and things like that. So that's that method. And finally, there is a method called component.catch, which is part of the error boundaries group. And this takes two parameters called error and info. And essentially, it gives us a chance to gracefully handle any errors that we run into. All right, so let's go ahead and call ignore prop. And also, when should component update do not render is called, we want to add one of the line markers so we know that's the end of the update. And let's call generate seed, and then we can still increment and decrement. We can unmount and remount it. And now let's generate a component that's going to create a deliberate error. So let's call this error component, and we're just going to return a div with it accessing some non-existent value, and this is going to cause it to crash. So let's say we add it into counter right now. So I'm going to place that error component here. When I save, you'll see that there were errors that were triggered here. Now, if I did not have component.catch, when I save, I lose everything that's rendered in the browser. And so I could have a downstream component that generates an error and it's not handled properly, and it causes the entire app to go into sort of this blank screen. So that's where component.catch comes into the picture. It allows us to gracefully handle some of these. So what I'm going to do is, once we know there's an error, we're going to set state and set the error and info properties on it, and let's handle those here as well in render. We're going to check for an error being present. In that case, we're going to return a div that says we have encountered an error. And let's try to print this out as well. The error has some additional attributes that we need to print. So what we can do is just print that out here to see what error contains, and then we can revisit this. There you go. It is re-rendering, but the error is right here. So let's go ahead and look for, I believe it's a message. There you go. Let's take this out, and all right, so we were able to handle our error gracefully without everything else crashing. And that's sort of the purpose of this method here. Let's trigger this conditionally. So what I'm going to do is add an attribute to state called show error component, and we'll set it to false to begin with, and we're going to pass that here, show error component, equals this.state.show error component, and everything still loads, but internally here I want to make sure that we're looking at props to see if show error component is true. In that case, we can generate this. So it's just actually made up entirely just so that we don't run into this and we can get the counter again as we toggle this. So we'll have to add another method here. Let's call this toggle error, and we're going to set the value there for show error component, and we're going to set it to negate it to whatever it's set to, and that should actually be called via a button here. So let's add that in, toggle error, and we'll just call this toggle error. And so I think, yeah, there you go. Now as we click this, it's not reversing. So let's take a look at that. I see what's happening. So this part works okay. I think the issue is with state.error. Because we are not clearing that, once we set it here, the component ends up rendering the error over and over again. So all we have to do is look at if props.show error component is true, and if we have an error. In that case, there you go. Now we should be able to toggle this. Let me do a quick recap. We have the constructor, which is called when a component is created, followed by get derived state from props, which allows us to copy props into state. This is not used frequently, but there are cases such as this one here where we want to pass in a seed for the counter and have that be controlled internally through the state. That's when this method is useful. We have component did mount, which is also an interesting place to do things like network requests or handle like the initial loading of the component. For instance, if we had a value that said initializing to true by default, and based off of this value, if we were setting a specific, if we were showing a specific message, we could sort of simulate, let's say we were simply returning initializing, right? So in this case, we're going to see that method there. I think if I add the div, it's going to show it on the next line there. And essentially, you know, let's say this is when the component loads initially, it's in the initializing state. We need to fetch some data, and that kind of stuff would happen right here. Let's just simulate this dot set timeout and call a method there in about, let's say, 500 milliseconds. So you'll see it flash briefly, and we're going to set the state on initializing to false. Sorry, I meant to do just set timeout there. And initially I was thinking about set state. So there you go. If I were to refresh this, notice you see the initializing followed by the counter showing up. So that's sort of the purpose of this method, where you could make a network request, and when you have your data again, you can change the state on your component and tell it to, you know, maybe perhaps show a spinner while it's loading content. Anyway, while we were doing the recap, so after component did mount, should component update gets called, this is where we could hint to React to not call render all over again. I believe in the future that's how the method's going to work. It's simply going to be a hint, and React will decide if it wants to actually honor that or not. And there's get snapshot before update, which allows us to store things like positions of your list views or you know, text areas or whatever DOM components that you can then pass on to component did update and reassign those after the render. Render, of course, takes care of rendering content. Component did update gets triggered right after render. Now this is also similar to component did mount. If you wanted to make specific network requests based on certain attributes or props or state values, you could do the same here. You can actually call set state in component did mount and it triggers a re-render, but it doesn't actually call the render method twice. It only does it once because of the location where it's called under. And finally, this component will unmount that gets triggered when the component's removed from the DOM, and component did catch, which helps us sort of gracefully handle errors in downstream components, lifecycle methods, or render method. And that brings us to the end of this video. Hope it was useful, and if you'd like to stay up to date with future videos, consider subscribing below. Thank you.